Detailed solutions on how to solve centroids of plane areas using integration. Here comes number 1. Find the coordinates of the centroid of the plane area bounded by x squared equals y and y equals x. First, graph the functions. Start with the line, slope is equals to 1, then locate where they intersected. Refer to the equation of parabola, vertex is at the origin and opens upward. Now, solve the area bounded by line and the curve. Let's just use a vertical strip. If you have not mastered yet solving the area, visit our other video regarding plane areas and it will come off easy. Get the value of y in terms of x. Limits must be from 0 to 1. Use the calculator and solve for area. In solving the centroids, we need to integrate the first moment of area and equate to the product of the area and the centroid. Tip number 1. You can always solve for the coordinates of the centroid using only one strip. The distance xc is the distance of the center of the strip from the y-axis, and the x-bar is the distance of the centroid from the y-axis, while y-bar is the distance of the centroid from the x-axis. Let's write the first moment of the plane area, that is area times distance x-bar, then equals to summation of the first moments of the differential areas, integral of differential area times distance xc, and that is 1/6 of x-bar, equals to integral of xc will be just x since we don't need to get its equivalent in terms of x, because it's already expressed as a horizontal distance. Then, substitute value of y we got earlier, that is quantity of x minus x squared times dx. Tip number 2, we only got the general formula for the areas or centroids, and it always start with what strip you will use. As you can see, since we used the vertical strip, the differential is in x, the limits should be in x, and all distance should be in terms of x. And we get x bar is equals to 1/2. Now, to solve for the y bar, we don't need to use the horizontal strip, we just use the same strip. Important is we understand how first moment of area works. This is the distance yc, it is measured from the center of the strip to the x-axis. For the second formula, if we use y bar at the left, we use yc at the right side of the formula. As you can see, differential area is the same, y dx, because it is the same strip, therefore limits are also the same. Now, yc needs to be expressed on terms of x. From the figure, yc is equals to y of the parabola plus 1/2 of y. Substitute the value of y of the parabola and the value of y, and we get the value of yc. Back to the solution, substitute the value of yc and y. Use the calculator. And y bar is equals to the fifth or 0.4. Now, let's just show what if we use the horizontal strip to solve for the centroids. And we got the same answer. Problem number 2. Find the coordinates of the centroid of the plane area bounded by the parabola y equals to 4 minus x squared and the x-axis. Graph the function. Solve the area using the vertica strip. By investigation, x bar is located at point 0. Use the calculator and store the value of area at A. We can now solve the y bar. And the centroids is at the point 0, 1.6.